Hi everyone. In this video we are going to be predicting the favorability of a reaction using the Gibbs energy equation, but this time we are going to do so graphically. If you haven't watched the previous video about how to predict the sign of delta G using just delta H, the sign of delta H and the sign of delta S, please go back and watch that video first. But we're going to attempt to do this by making some diagrams. So we're going to graph energy, whether it's Gibbs free energy or enthalpy, on a y-axis. And again, we're not using numbers, we're just using signs for delta H and delta S. So let's say we have a negative delta H and a positive delta S. What would that look like on our diagram? And one other thing, we are going to use the same trick that we used last time, which is that we're going to rewrite the Gibbs equation as delta H plus a negative T delta S. And I think that's going to make it a little easier to think about this problem. All right, so if we have a negative delta H, we're just going to pick a random starting place. It doesn't really matter where, all right, random starting place. And the delta H term is going to be negative, so we're going to draw that, we're going to represent that as a down arrow because the delta H is negative. Now, if we have a positive delta S, remember that a positive delta S, and the temperature is always positive, so we don't have to worry about it. But that means that our negative T delta S term is also going to be negative, right? Because we're plugging in a positive delta S here. That makes this whole term negative. So that means that this is going to go down more when we look at the minus T delta S term. And so overall, the delta G, which is the sum of the delta H and the minus T delta S terms, is going to be negative, all right? So all we're doing is we're representing the magnitude and the direction of the delta H and minus T delta S terms with arrows. So the larger the term, the longer we're going to make the arrow. If it's negative, we're going to make the arrow go down. If it's positive, we're going to make the arrow go up. So now let's do the next example. Let's do one of the more interesting examples. Let's do delta H negative, and let's do delta S also negative. So again, we're going to draw our energy axis on the y, have a random starting place. Now we have a negative delta H, so that part's easy. So the delta H is we're going to represent with an arrow going down. But what's going to happen that's odd is that the minus T delta S term, because you have two negatives, right? We're specifying a negative delta S. We have the negative sign out in front of the term. That's going to make this term positive. So now we had a down arrow for the delta H, but the negative T delta S term is actually going to be positive, and it's going to go back up. Okay, now how far it goes up depends on the temperature, right? So I've drawn it at a lower temperature where the length of the arrow is smaller, all right? So this is for a low temperature. But I could also draw it for a higher temperature. A higher temperature one would look more like this, where the minus T delta S term is actually larger in magnitude than the delta H term. In this case, in these two cases, you get a different answer for what's true of delta G. In the low temperature term, in the low temperature case, we would get a negative delta G, right? Because in order to join these up from our starting place to our ending point, the delta G, which is the sum of delta H and minus T delta S, would be negative. It has to go down to meet up with the T delta S term. So that would be a thermodynamically favorable process. Okay? That would be thermodynamically favorable. Whereas in the second case, our delta H goes down, but our minus T delta S term goes up. So then our delta G, getting from the sum of delta H and minus T delta S, the delta G would now be a positive number. And so this case at high temperature, this would be a thermodynamically unfavorable process. Okay? And you can draw these diagrams to help you figure out, rather than doing the same work that we did in the previous video, you can draw these diagrams to help you figure out if a process is thermodynamically favorable at low or high temperature. The trick is to remember that a negative term is going to be a downward arrow, a positive term is going to be an upward arrow, and this minus T delta S term, the length of that arrow can change based on whether you're plugging in a small value for temperature or a large value for temperature.